Here is the 3E. Describe how wavelength of unknown source be determined with the help of Fresnel's prism. So I have given a video link in the description box. I have written 3E answer, and then I have given the link in the description box. Please do watch that video so that you can understand it properly. And there is a numerical part. A thin sheet of transparent material of refractive index placed in the path of the one of the interfering beam in a biprism experiment using the sodium light of wavelength 5890 Armstrong. If the central fringe shifts to a position originally occupied by 12 bright fringe, then calculate the thickness. And I have already explained in that video that I have given the link in the 3E, in the video link where I have explained how to determine the wavelength using Fresnel's prism. I have also explained how to determine the thickness of the sheet. Okay, now we have to solve this problem, numerical problem. So there is a mistake in this question, that here you see, if you read the question, a thin sheet of a transparent material of refractive index is placed. So what is the refractive index? That is not given here. Okay, so that's supposed to be given. Okay, now you see in Fresnel's prism, this is the source. Okay, then the light through the upper half refracted downwards, and through the lower half refracted upward like this. Okay, and it can be and also virtual images of this source formed this way, right? This is S1 and S2 like that. So we can compare it with Young's double slit experiment like this. So here S1, S2, right? We can compare this. This is the position of central bright, and on giving the thin sheet in the path of in the beam part of the beam of light, so it shifts to the position which was originally occupied by 12 bright fringes. Okay, now the thickness of this sheet is given by this formula. T is equal to xd by d mu minus 1. Okay, and this is the distance d, and this distance is small d. Okay, right? But here you see these informations are not given here. Small d, capital D. Okay, these are not given. And x is this is the x. Okay, the shift of the original position of the central bright fringe, and this x can be obtained by n lambda into capital D by small d. So if you use this value here, okay, from these two equations we can write T is equal to, actually if you put this one here instead of x, then what you will get, that instead of x, if we put n lambda d by small d into small d capital D minus into mu minus 1, here d will be gone, this one will be gone. So then the expression will be like this, n lambda by mu minus 1. That's what we're gonna have. So here we have lambda is equal to here 5890 Armstrong. So that is 589 into 10 to the power minus 10 meter. Okay, if you write in meter. Then refractive index, I have already mentioned here, refractive index is not given. So let me take, just for to explain this, let me take the refractive index is suppose approximately 1.6. let me take that way. So it's such a material, its refractive index is 1.6. It is not given in the question. It should be given but not given here, so that's why I have taken this. Okay, let us consider this. So here value of n is equal to 12 because it is shift to 12 bright fringe. Okay, so If we put these values here, then n is equal to 12, lambda is equal to 5890 into 10 to the power minus 10 divided by 1.6 minus 1 meter. So now if we calculate this using calculator, we will get this into 10 to the power minus 5 meter. Okay, you can calculate without using calculator as well. I have used calculator, so I am not saying that you must use the calculator. Okay, so now you see here you see this one minus this one, that gonna be 0.6, and if you remove the point, you can make it 120, then you can cancel it by 6, then you will get 20, right? Then you multiply with this one, and then what you will get, just hope you can do the calculation by yourself, right? Okay, now you see then let me show you how to do it. Just wait, sorry. So how to calculate this? Now you see we can write this one is 0.612 into 5890 into 10 to the power minus 10. If you make it 6, then it will be 120. If you cancel this, that's gonna be 20, right? Then let's multiply this two, right? Then what you will get, 0 0 2 9 is 18, 2 8 is 16, plus carry 1 17, carry 1 2 5 is 10, 11. That's what we're gonna have into 10 to the power minus 10. Okay, now the decimal is here. Now if you bring it here, then what you will get, 1.17800. so how many digits you have shifted this? 5 digits. So here we can make it 10 to the power 5, right? 10 to the power minus 5. Okay, here you see now, so this is 7 8, you can make it approximately 1.18 into 10 to the power minus 5 meter. That's what we have done, right? So that's how we have got this answer, right? So hope you have understood this. Now I have already made a video on this question 3F. Okay, so link is in the description box. I have written question number 3. Let me clean this. Sorry, 3F. I have written question number 3F, then I have given the link. Okay, now let me answer to this question. Okay, so here you see this is 3G, answer to 3G. This is the definition of zone plate. Okay, so take the screenshot, and here let me explain the action of this zone plate. Now here you see this XY represent the section of the zone plate. This XY, here you can see, and the section of the zone plate perpendicular to the plane of the paper. Perpendicular to the plane of the paper means the screen, that this is your screen, this is the screen of your mobile or the device which one you have used to watch this video, and this zone plate is perpendicular to this screen, like that. Okay, this is your mobile screen, suppose, and this is the plane of the section of the zone plate, section of the zone plate, right? Hope you have understood this. Sorry. Now you see here S is the point source. Where is S? This is the point source, okay, of light, and P is the position of the screen. So here is the P is the position of the screen for a bright image. Here we get bright image, okay, at point P, and A is the distance of source from the zone plate, and B is the distance of the screen from the zone plate. From the zone plate, the distance between the zone plate and source is A, and distance between the screen and the zone plate is B. Here you can see, right? And here you see this point O, this O M1, then O M2, this is O M1, then O M2, then O M3. Here are equal to R1, R2, R3. Radii of first, second, third, half period zones. Hope you know what is half period zones. Hope you have the idea of Fresnel's half period zones. Okay, so now you see the position of the screen is such that from one zone to the next zone is increasing path difference lambda by 2. So here you see the path difference here. Now you see this part S to P, this part is A plus B that I have written here, right? Okay, and next part you can see this part, this M2 is this point. Okay, this point is M2, this point is M3, and this is M1. This one is M1, this one is M2, and this one is M3, right? Hope you have understood this. Now this part you can see, this one, this SM1 to M1 to P, that part is A plus B plus lambda, A plus B plus lambda by 2. Okay, that means this part is longer than this part by lambda by 2. Then the next part, this above part, SM2, this is M2 plus M2P is longer than this part by again lambda by 2. So that's why we're gonna get A plus B plus 2 lambda by 2. This is what we have got, and so on, right? So hope you have understood this. Now you see, let me clean these things. Now you see, from triangle SM1O, SM1O, which one is SM1O? This is SM1O, this triangle, SM1O. Okay, so this one, here SM1. From this triangle, if we use Pythagoras theorem, we will get SM1 is equal to this, right? And this is R1. Okay, that's why we have got this expression. Similarly, if we take SM2O here, let me take not SM2, from OM1P, where is OM1P? From this triangle. Okay, from this triangle, from the left hand side, triangle on the left side. Okay, from this triangle. Now what we will get? We will get M1P. Okay, this part, this triangle, M1P, this length is B, this is again R1. Again here, if we use the Pythagoras theorem, then we will get this result, right? So now let us use these values in equation number 1. So we're going to use this in equation number 1 here and here. So using Pythagoras theorem, we have got M1S and M1P, and we have put those values here. Okay, so then we have got this. So after simplifying this, we have got this result. Okay, so this is for R1. Similarly for Rn, we will get this relation. Okay, we will get this relation. Then if we use the sign convention, then we will get this, right? And this is similar to this Lenz's equation. Okay, Lenz's formula, right? So that's why a zone plate, you can see acts as a converging lens. Okay, so hope you have understood this. Now remaining questions will be solved in the next video. Thank you for watching.